Hi all, welcome to another webinar session conducted by Slascom Quality Forum. As for now, we have nearly 78 participants, so I think this is a perfect time to start today's session. So on today's session, it's all about performance testing and how performance testing can be carried out in the DevOps world. I know most of you might aware of what is performance testing, which means measure and evaluate the speed, responsiveness, and the stability of the system. But the interesting thing is how this is going to be incorporated with DevOps. Because from the DevOps, the word, it, it will create a picture in your mind with a rapid release, shorter system development life cycles, continuous delivery, plus high quality outputs. So, what are the challenges that we are facing when we are dealing performance testing on a DevOps environment? So, to explain those things, today we have Gaushi, also known as Gousalya Ramachandran from Bistec Global Service Private Limited. So, before starting the session, let me give a quick introduction about Gousalya. She has been working in software engineering field for more than 3 years, involving in domains like aviation, tax and audit, IoT applications, and much more. And also, she has a solid knowledge in manual testing, automation, and performance testing too. So, to start today's session, please welcome Gousalya Ramachandran. Gousalya, it's over to you.
Thanks, Chatura, and thank you everyone for joining with us today. So today we will be talking about performance testing in the DevOps world. So in this session, we will be starting with a brief intro on what DevOps is, how quality is implemented within DevOps, and the challenges that we face when implementing this quality, especially when it comes to the performance aspect of it. After that, we will discuss the scenario where performance test is executed only before a major production release and its impact on the application stability and the delivery timelines. So for this problem, we will discuss what type of solution that we can provide with and the best practices we can follow to implement a performance test framework that is ideal for our project. So when we talk about DevOps, most of the new projects that are coming in the market are implemented with a DevOps team. Even the projects that have some projects that have previously used waterfall model are now turning into a DevOps culture. So this is because of the fast feedback characteristics of DevOps. So in order to achieve this fast feedback character, we go through rapid releases and an end product that has minimal disruptions or defects. So every release needs to come up with a product that is up to the customer expectation and provides a quality user experience. So when I say quality, it is not only about the functionality, but it's also about the performance, usability, and security of that application. So as a QA, we involve from the planning to the deployment phase to ensure this quality level of the application is achieved. So most of the time, the functional quality of the application is almost achieved using extensive manual testing and ad hoc testings, even automation to an extension where we perform scenario based automation using behavioral driven development frameworks. But performance is also an important aspect when it comes to the quality of an application. Performance actually gives the first impression for the user when he navigates to that system. So even for us, the first thing that we notice in an application is the slowness or the performance of that application before the good functionalities. But how often do we focus on performance within the software cycle? We only focus on this when we come across a production issue related to performance or when we need to execute a performance test before a production release. Why is that? This is because of the challenges that we face in DevOps. The first challenge is the time. Simply, we do not have enough time to execute a performance test. So we have 2 weeks within the sprint cycle. So within 2 weeks, the project team goes through requirement analysis, planning, designing, development, testing, and ultimately the product deployment. So as a QA, we involve from the requirement analysis, we derive the test scenarios, we test the application, we identify the defects, we verify the defect fixes, and ultimately to bring that product to a stabilization phase. So along with these activities, we do not have enough time to execute a comprehensive performance test. So what I mean by comprehensive is a complete performance test on that application, where we conduct a requirement analysis phase for the performance requirements. We derive the scenarios from the requirement, we execute the test, and we identify the results through result analysis. So with an overwhelming workload of the sprint already, we do not have enough space or enough time to execute this much of an extensive performance test. So most of the time, the performance test is actually delayed to a favorable time, that can be conducted by the project team, which becomes the end of the product life cycle or before a production release. So the next challenge that we face is ignored non-functional requirements. What I mean by ignored is it's deprioritized or less prioritized. So generally, the performance requirements are only captured when a performance test is expected to be executed. But at this moment, most of the modules are brought to stabilization phase. So when after they are brought to stabilization phase, when we find a performance defect, this defect can either be in the application functionality or it can be in the design. So fixing this defect reduces the application stability and brings up more regression cycles that we need to perform. So for an example, let's consider a drop down that populates the details with an as an option from the backend. So this drop down can be designed in many ways, but according to the performance requirement, we should select an ideal design that is applicable. So if the drop down, depending on the production load or depending on the data rows that are getting populated in this drop down can be performed with a design that is populating all the options on load, or a drop down that only populates these details when a relevant search criteria is provided. So depending on this non-functional performance related requirements, a design can vary vastly. So if we do not capture them at an early stage, we can come across even design related issues at a later stage of the test software cycle. So if the non-functional requirements are not captured in the requirement gathering phase, testing and developing for the NFR requirements also, the chances are minimized. So we won't be even thinking about developing or testing with non-functional requirements if those requirements are not captured in the requirement phase. So the third challenge that we come across is the continuous requirement changes. So because of continuous requirement changes, functional testing becomes a priority. So let's discuss about both of these challenges together. So with the fast feedback characteristics of DevOps, we can expect continuous changes in the requirement. So when we are trying to implement these changes, most of the stable modules in the application gets affected. So this triggers a number of regression and retesting that needs to be executed. So especially we know that even a small change in the code can trigger a complete regression cycle. So with these continuous changes, there is a relatively high number of regression retesting that needs to be executed. So functional testing is always a priority when it comes to an application, but with more number of regression and retesting, functional testing actually demands most of the QA's time within the sprint cycle, which again reduces the probability of executing any type of performance test within the sprint. So this issue is actually more prominent in projects that have not implemented automation to satisfy their functional test scope at any level, which is again another problem in the poor implementation of DevOps process. So because of the issues that we discussed above, performance test is actually carried out most of the time only before a production release. So performance test is actually carried out as a centralized service rather than a continuous testing experience. Simply there is a performance test team in the company which will execute the test on projects when required. So to give a brief on the performance test steps that are carried out, we will be gathering the requirements, performance related requirements from the client, and we will analyze these requirements and identify the business scenarios, the type of test that we need to execute, the number of users who are going to, the user load that we are going to execute within this test. And with these details, we'll be deriving the test scenarios and we will be creating the test for the complete application. After that, we will execute and analyze the results of the execution. So this execution and analysis iterates until the success criteria or the objective of the performance test is met. So this actually can span up to the time that is equivalent to another new sprint or even more depending on the number of defects or the test scope of the execution. So apart from that, we also perform extensive scripting. So when we script for this particular application, we will be scripting for the whole functionalities in the application. So for that, we need more time and we need to perform complicated correlation techniques. So apart from this, we also need to set up the load generator and upload the test data in the test environment. So because of these time consuming tasks, it becomes very hard for us to perform a performance test at the end because of this extensive scripting that we need to perform. So after extensive scripting, we execute the test manually and identify the performance issues during the execution. So it's really hard for us to isolate the root causes of these defects, as the root cause can be either in the infrastructure, it can be in the platform, it can be in the network or in the application. So we need to run this test multiple times, changing these parameters to identify the location of the issue. For an example, let's take an API that takes a very long time to respond. So this can be due to the fact that there is a poor implementation of this particular functionality in the application. It can be due to the network lag between the client and the server. It can also be due to the fact that the application server is responding fast, but the database hasn't opened enough connection to accommodate this load. So because of this, the API can take a longer time to respond. That is the visible defect that we find. So to identify this root cause, we need to execute the test repetitively, changing some of the external parameters. So for this particular example that I took, we can identify the server related issues using the server logs easily. So after fixing that, we may come across the buggy code in the application. So after fixing that, you will come across the network lag between the client and server. So even for this, we need to manually execute and analyze the results repetitively to find the root cause and fix it. So even fixing a defect is tiresome in this particular model. So if it's an infrastructure defect, we can fix it very easily. But if it's an easier than the application defects, if we fix an application defect, the application defect can either be in the code or it can even be in the design. So fixing this triggers another QA cycle or another regression cycle that needs to be executed, which ultimately delays the delivery timeline. To summarize above points that we discussed, this particular model actually is time consuming. Isolating and fixing the defects are difficult, and fixing triggers a new QA cycle that needs to be executed, which we cannot afford with the limited time constraint. So also you can see the performance test is actually executed as a waterfall manner, contradicting to the other DevOps characteristics of the project. So with continuous changes in the code, we have to test for performance continuously. So executing an extensive performance test only at the end before a major release, or executing this much of an extensive test within every sprint, is not an option for us. So we need to come up with a solution where performance becomes a focal point throughout the software cycle in a way that it doesn't impact the delivery timelines. So for this, we can come up with many solutions ideal for a project requirements. In these solutions, we need to implement some of the best practices to come up with an appropriate performance test framework that is applicable for a performance requirement. So in this session, we will be talking about 4 such best practices, which is performance designing, continuous performance testing, proactive monitoring, and smart testing. So when let's discuss a brief on each of these, and we will elaborate this in the next slides. So when we talk about performance designing actually focuses on identifying the known performance issues early, even before testing, if the relevant requirements are provided. So for an example, the drop down example that we took previously, if we know the performance requirements early, we can come up with a solution that is ideal for that requirement, eliminating or reducing the time or reducing the possibility of this particular design issue coming at a later stage. So also, executing performance test at the end is not an option for us. We need to have a mechanism where we can execute performance tests for the new features within the sprint and perform regression performance test on the impacted areas in a manner that it doesn't impact the delivery timeline. The solution for this is continuous performance testing, where we create component level scripts within the sprint, which as the sprint progresses, we can aggregate these component level scripts to create an application level performance test suite. So using this application level performance test script, we can either execute an automated regression or a scenario based test execution. So we cannot also a main thing when it comes to performance is identifying performance issues in the production. So this can actually impact the customer usability adversely. So we need to identify some of the performance threats early before they become a failure. For this, we can implement proactive monitoring. There can be unexpected issues, yes, but some of the known issues like increasing customer base, increasing the number of users accessing the system, increasing the infrastructure utilization, or degradation of the infrastructure. So these things we can identify them early and fix them or propose a solution for them before they cause an application failure and impacts the customer. So the last but the important thing that we can do is smart testing. So performance test is a must for us to execute, but not manual performance testing. So we need to come up with some smart solutions to reduce the time that we take in these performance tests. So for this, the solution that we can propose is to reduce the time that we take on preparing the setup, creating the script, executing, and more time on the result analysis and defects identification. So we can do this by using simple load generator step setups. Even for smart testing, we can come up with tools that are applicable for our requirement, tools that allow us to do easy correlations and reduce the time we spend on scripting. Also, we can schedule our execution to perform at an off time, so we have more time in focusing on the result analysis. So this actually allows us to execute the test even repetitively, because we will be only focusing on the result analysis phase and the rest is automated. So let's discuss a little bit more on each of these best practices. So when we talk about performance designing, as I mentioned earlier, we can eliminate some of the known performance issues if we know the relevant requirements at an early stage. So for this, we need to make the performance related SLAs a focus area in the planning and designing phase. We can do this by deriving the requirements from the customer related to performance on the same time that we are deriving the functional requirements from the client. So if we are executing, if we are actually working on an internal product, we can come up with this requirement by studying similar applications that are already in the market. So with this requirement, we can design an application that balances both the aesthetic and the performance. So what I mean by aesthetic is we can come up with web pages that have good layout and interactive content, but doesn't impact the page load time or the customer experience adversely. For this, we can take an example of a report that just populates the details from the database. So the design or the implementation for this report can vary vastly. We can propose different types of implementation solutions for this. But depending on the performance requirements, we need to select an ideal solution that is applicable for us. So the performance requirement for this particular report would be increase the number of users who are accessing the system, how frequent they will be accessing the system, and the data load that is going to get populated in this particular report. So using these requirements, the design varies completely. So if multiple users are accessing this report frequently, we will not propose a solution where all the data are populated on load, right? So we will be proposing a solution where there is a filter criteria, and when you select that filter criteria only, the relevant data will be populated. But if this report is only accessed by number of users or limited number of users, occasionally we may even propose a solution where all the data is populated on load, provided that the proper weighting and loading mechanisms are implemented. So this actually shows us how much of an impact performance requirement has in the planning and the designing phase, because depending on the customer performance requirement, the application implementation varies vastly. So knowing these requirements ahead reduces the time we spend on the rework, and ultimately saves us a lot of time. So also, if we know these performance requirements early, we can identify the performance scenarios for these new features and also plan for the regression performance test within the sprint. So the next thing that we will be talking about is continuous performance testing. So in continuous performance testing, what are we trying to eliminate is uh, executing performance. Rather than executing performance test at the end, we are trying to bring that as early as possible within a software cycle. So with the speed of the DevOps, we cannot only execute performance test at the end. We need to be we need to have a solution where we can execute the test at a component level and also for the regression performance test. So for this, we use continuous performance testing mechanism. So the application level performance test script that is created in the continuous performance test, we can use it to execute automated regression performance tests within the CI/CD pipeline, or even scenario based test executions. So with these continuous executions, we can create a baseline. So baseline is a successful execution of your performance test that meets the objectives of your test. It is the most healthiest execution which you can use to compare with the other continuous executions and create a trend. So there is some key points that we need to follow when it comes to the continuous performance test. So the first thing is the goals change. So as your requirements change, your test goals also change. So what I mean by test goals is your success criteria or your objectives of your performance test also change. So within your continuous performance test implementation, you need to be able to implement these changes successfully. So most of the performance test solutions allows us to implement these success criteria easily and configure them simply within our test scripts. So the next important thing is automation. So automation is an important factor when it comes to the continuous performance test. So if we even automate a limited number of tests within our CI/CD pipeline, we can identify the performance stability even before the production release. So with this, we can actually, rather than waiting for the client to provide us with a fast feedback, we can identify the feedback or identify the performance stability before it is even released to the client. So automation is an important factor when it comes to continuous performance test. We may not be able to automate all types of tests, especially high concurrency load test, even endurance tests. We cannot automate those. At least we can automate up to an extent of a performance test within a CI/CD pipeline to make sure that our releases are performance stable before push to the client. So the next important thing is shift left performance testing. So shift left performance testing focuses on bringing the performance test as early as possible within the software lifecycle. So for this, we focus on individual component testing. So individual component testing can be brought earlier for a earlier within a sprint, and we can execute them also easily. So here we perform only component level testing. So within this, we only understand the individual impact of these components and identify them early and fix them early before we aggregate it to a application level test execution. So the next thing is shift right testing. Yes, we can perform shift left testing, but we also need to perform a similar amount of shift right testing as well. So in shift right testing, we focus on soak tests or high concurrency load test. So with soak test and high concurrency load test, we can identify the integration quality or the server performance as well. So these are the metrics or application level metrics are the ones that are focused in a so shift right testing. So the next is the baseline changes. With the constant changes in requirement, there can be external parameter changes as well. There can be infrastructure that can scale up and scale down. So depending on this, your baseline needs to be redefined. So if your infrastructure has scaled up, your baseline is not valid anymore. So you need to discard your baseline and you need to retest it and redefine your baseline before comparing it with your other executions. So these are key points that we need to consider when we are executing a or when we are implementing a continuous performance test. So this is a sample illustration of how we can implement continuous performance test. So here I've taken test scope as component level, automated regression and scenario based execution. So in component level, we will be testing the individual component or the API with less or medium complex test cases. So what I mean by less or medium is here we can actually execute tests like checking the concurrency, the data population, even authorization. Like if one user is accessing and if one user's authorization is used multiple times or if multiple users authorizations are used. So likewise, the individual component level performance tests are conducted at this stage. So also I have mentioned here that we can execute this parallel to the development or testing. So here some may have a question of, so there can be integrated APIs with this, right? So where we need to send some of the previous APIs details within this particular API. So without that, how can I execute an individual component testing? For this, you can actually use mock services like mock, which allows us to simulate these interactions so that we only focus on the individual components. Also, mock allow this is an actually a good this is actually a good implementation, because then we can even we can even eliminate the third party integration times also from your individual component testing. So your test is solely focused on the component that you're performance testing. So after component testing, you may perform automated regression on your impacted areas. So also when you're doing automated regression, you can use the application level performance test suite that you've created in with the sprints. So with this automation, with this application suite, you can come up with a regression suite and implement it within your CI/CD pipeline. So when you implement this, you can either execute it in every release or on demand. So here one thing I wanted to mention is automated regression is actually costly. It takes a lot of resources. So executing it after every release might not be a solution for everyone. So we even can make it available within a CI/CD pipeline and only manually triggered whenever it is required. So for this type of test, we actually use smaller load tests. So what I mean by smaller load test is we may take most common scenarios that are mostly used within the business for that application and create a smaller load test that can execute for the automation. So the next thing is scenario based execution. So in scenario based execution, what we focus on is high concurrency load tests or even endurance tests. So these types of tests are not possible to execute with a build pipeline because they take about 4 to 5 hours to execute, and implementing such an extensive test for a build pipeline actually reduces the fast feedback mechanism of our DevOps projects. So we may execute them on demand in a weekend or at an off time, or a time that is applicable for us. So these tests we can execute also using a application level performance test suite that we've created. So the next best practice that we are going to talk about is smart testing. So generally, performance test is executed manually. So this manual execution itself is, we cannot perform it repetitively, and it's not an ideal solution for us within the DevOps cycle. So we need to come up with smart solutions for the steps that we carry out within the general test execution. So this is a comparison of the general tests that we carry out and how we can come up with smart solutions for it. So we can replace setting up and maintaining load generators using simple setup and tear down load generators. For this, we can even use virtual machine instances, container instances, or even cloud performance test solution to reduce the time that we spend on setting up the load generators. So the next thing that we focus on is extensive scripting. We can reduce the time that we spend on extensive scripting using fast and flexible scripting mechanism. For this, we can use uh, record and playback. We can even use simplified correlation techniques, which is dependent on the tool that we select. Also, we can even use a tool that is applicable for a requirement. So choosing an appropriate tool also reduces the time that we spend for a scripting. The manual test execution and data collection. So this can be replaced by scheduled execution with automatic data collection. So for this, we even can use cloud performance tools, or JMeter even provides us with an extent of scheduling mechanisms. So this in turn, all of this actually reduces the time that we spend on the setting up, script creation and execution, and more time on the result analysis phase. So this is an example of how we can implement smart testing. So using virtual machines for setup and execution. We can use virtual machines or even container instances to set up a load generator distributed setup easily. So here I've given an example of how we can implement this using a containers in Azure. So we can create the distributed setup with using Azure containers, and as we only pay for the number of hours or number of seconds that we've used, this can be an affordable solution. Or we can even use cloud-based performance test solutions. So when I talk about cloud-based performance test solutions, what I'm giving an example here is BlazeMeter. So BlazeMeter allows us to simply create a load generator distribution setup where the generators are located in different regions of the world. So easily we can create a public user site simulation using this BlazeMeter cloud performance solution. So the next thing is, after setup, we go to the test development phase. So in test development, we should select a tool that is based on your requirement. So here I've given K6, Load Ninja, and JMeter. So all these three can be used to create an HTTP request performance test script. But if you have already used K6 for your automation, you can simply create a performance test suite for the relevant HTTP request using K6 with JavaScript. But if you're actually populating some data from the database to your request body, K6 may not be an ideal solution. You may go to JMeter because JMeter allows us to simply create this by using JDBC plugins. Also, JMeter provides us listeners to see these execution results graphically, and it's an open source tool. But if you have a fair budget and your focus is on browser based testing but not protocol based testing, then your solution might be Load Ninja. So likewise, choosing the right tool actually allows us to reduce the time that we spend on scripting, or to allow us to spend the time scripting time wisely. So most of the performance test tools provides us with record and playback mechanism, and most of the commercial tools also give us easy correlation techniques. So even for the test development, we can eliminate the third party interactions or third party APIs that we talk to using the mock services like Biomock. After test development, we move to test execution. So at test execution, we can schedule the test to execute at convenient times. So this is an example of how BlazeMeter allows us to schedule the test. So we can schedule this to execute either frequently or on time depending on our requirement. Also, after scheduling, we need to define the success criteria for our test. The success criteria can be defined in a way that if the test is executing, it automatically fails or passes the test depending on this success criteria. So here is an example of how BlazeMeter allows us to define these success criteria. So here at the key performance indicators, we can define the response time, average response times, the error rate, the time it takes to execute, etc. So using these, we can actually create a smart solution for our test execution. So apart from that, an important factor in execution is the environment and the test scope. So if your production environment and your testing environment is of different specs, your test scope should also be scaled down according to that. So let's say your production environment is of higher specs and your uh, testing environments one-fourth scale down. So relatively, your test execution should be also test scope, or the number of users you're taking in also need to be scaled down appropriately. So this is an important factor when it comes to the test execution. So the next thing is result analysis. So using the load generator tools and the server monitoring tools, we can come up with the results and analyze them effectively and identify the issues with the results. So this is an example of how BlazeMeter shows us the test results for a single execution. So even JMeter provides us with aggregate graphs, aggregate reports, and displays these test results in a manner that we can come up with easy decisions. So here, apart from the single execution, we can also compare multiple executions with a baseline to identify the trends or the failures of our execution as well. So the next thing that we are going to talk about is proactive monitoring. So proactive monitoring is a technique that allows us to identify any threats before they cause a visible failure. So proactive monitoring actually increases the reliability and efficiency of our application. So with continuous monitoring platform, we can reduce the number of unexpected performance downtimes that can come in the application. So proactive monitoring can happen in the infrastructure, it can happen in the platform, it can happen in the application and in the business. So when we talk about infrastructure, we focus on the application servers, the database servers, the load balancers, and even network as well. So checking the health of these infrastructure devices is an important aspect for us, or it's the basic requirement for monitoring. So for an example of such infrastructure tool is Splunk. So Splunk is an infrastructure tool that we can use for proactive infrastructure monitoring. So this allows us to even monitor Linux and Windows servers and create real-time alerts as well, depending on the health of the servers. Also, Azure allows us to monitor the Azure infrastructure components, where we can monitor the health, the CPU utilization, available memory of our application and DB servers. So the next thing is monitoring the platform. So in monitoring the platform, we focus on the database, the messaging platforms, the caching mechanisms that are implemented. So checking the health of these platform components is also an important aspect for us. So most of these platform components provide us with an interface, but most of them actually gives us an API that we can integrate to a main monitoring platform so that we can easily view the health of these platform components as well. So the next thing is monitoring the application. So having a healthy infrastructure and a platform is not good enough for an application to function correctly. So proactive monitoring of the application is needed to be performed. So this can be executed either before a release or after a release. So before a release, we can monitor the application proactively using continuous performance testing, where in every release we can compare the performance test metrics like average response time, average hits, latency, etc. with the baseline and identify the issues or identify the uh, failure criteria and the trends of our execution proactively. The next thing is we can monitor the application performance after the release. So for this, we may monitor the client apps, the web services, the background services, and create reports or alerts depending on the real-time alerts depending on the performance of the application. So this is how Azure App Insights handles the proactive monitoring of application. So after monitoring the infrastructure platform and the application, we also need to monitor the business. So the application runs in the production to meet the business goals. So you can have an application that flawlessly runs in a very good infrastructure, but it may not still meet the business goals. So for an example, increase in the customer base, which happens day by day, increases the number of users who are accessing our application. So this again needs to be addressed because increase in the number of users can affect the application, the platform, and the infrastructure. So knowing this information early is very important for us. So if we know this information early, we can implement fixes or enhancements in the application, the platform, and the infrastructure before it becomes a issue issue for the customer. So we can identify these issues, identify the business trends using reports which will populate the data from the database and the application insights and create a business trend graph for us so that we can identify the business related issues, threats early and fix them before they become a failure points. So this is an example of how Power BI allows us to do this facility. So uh, this is how we can create a this is how we can use the best practices that we've discussed to come up with a performance test solution that is ideal for our execution, ideal for our projects. So during planning phase, we can discuss the performance related requirements and design for the performance of new features. After that, using these performance requirements, we can identify the features that needs to be tested for the performance and push them for the component level performance testing. So for the impacted features that we identify with the performance requirements, we can plan for the regression performance and push them for the automated regression. Also, with the proactive monitoring, we may have come across some performance issues. So we need to fix these issues to and push them for either automated regression or on-demand test execution. So in component level, we can execute performance test even within the sprint, where we can create component level performance tests and execute the test for individual components using mocks. So if our components are web pages, we can actually use Lighthouse or even a performance tab in the Google Inspector, even web page test like softwares to perform a front-end performance testing. So if it's an API, we can use even JMeter to test the performance of that individual component. After that, if this component is actually valid, we can actually promote it to a regression suite. So after that, we have to choose the type of performance test that we are going to execute. So as I mentioned before, not all types of performance tests are applicable for the test automated execution. So we need to select the types of performance tests that we need to execute within the automated regression. So after identifying the type of test, we need to establish the success criteria. So within the automation test itself, you can define the success criteria of your uh, performance test. After this, you can automatically execute a test, and depending on the success criteria, the test will either pass and the release will be deployed, or it will fail and the release will be terminated. So after that, you can get the performance test reports, the logs from the release pipeline, and view the trends of your performance test execution as well. So this automated regression actually can be implemented in Azure DevOps using JMeter natively, or if you want, you can even use BlazeMeter or Flood.io like third-party plugins to create the automated regression suite. So if you want to see the trends of your performance test execution with a baseline, you may even go for BlazeMeter and Azure DevOps. So you can see the trend of your JMeter test execution in the BlazeMeter plugin. So next we will be talking about on-demand test execution. So we can execute the high complicated tests like endurance test, extensive load test using a cloud-based solution which allows us simple setup and text execution. So after this, as a test engineer, we only focus on the validation of the test results. This also can be implemented using BlazeMeter and JMeter. So that brings us to the end of our presentation. So to summarize the main points, performance related SLAs are an important requirement. So with these requirements, you can plan and design your application for the performance. Also, this allows us to identify the known design related performance issues early and come up with a solution before the stabilization, so we minimize the risk of finding the design related performance issues at a later stage. Further, we need to create a performance test scope depending on the environment. So this is not only important for performance test in DevOps. For any performance test, we need to come up with a test scope that is proportion to the environment that we are executing. So performance test also should be tested continuously. Only testing at the end is not enough for us. Apart from creating or planning and testing the application, we need to monitor the production or monitor the application proactively to identify the threats before they become a failure. Further, if you're executing scenario-based tests on an application, you can reduce your setup and scripting time using some smart techniques. So all of this should be implemented according to your project goals. So what I mean by project goal is your test requirements, and the most important thing is the time and the budget constraint. So especially when you're planning for the automated regression, you should be really mindful about the scenarios that you're going to execute, the number of user load that you're going to perform this, and the frequency of your execution. So planning for the performance test where we plan and design can be done easily. It can be implemented very easily. But the rest of the rest of the steps need to be carefully evaluated and carefully implemented according to our project goals. So that brings us to the end, and thanks again for everyone for your time and attention. So back to you, Chatru.
Thank you, Gousalya. So this is time for the questions. Please leave a chat message at Zoom if you have any questions. Yes, there's a one question not related to specific for this topic. Yes, this video will be available in Facebook in our /com page, so you can get it from there. And also, this video will be published to our YouTube channel, maybe within another 2 or 3 days. Seems to be we don't have any more questions related to the topic. So participants, now it's your time to apply these things to your projects and see the outputs. Please keep trying on these things and feel free to leave a message at our Facebook group if you have any issues related to this kind of testing or the topic related to today's one. With that, I believe you have learned so many new things, tools, technologies, concepts, and problems, and how to overcome those things when dealing with performance testing on a DevOps lifecycle. And again, Gaushalla, thank you very much for your wonderful time and valuable knowledge which you shared with the participants. Finally, I would like to thank you all for joining today's session, and we will meet again with another wonderful and interesting topic in next month. Till then, stay safe, stay healthy. Thank you all.